What is going on, everybody, and welcome to yet another Deep Learning with Python, TensorFlow, and Keras tutorial. In this tutorial, we're going to continue with the last tutorial where we are attempting to predict future price movements of a certain cryptocurrency based on the sequence and the historical prices and volume of that cryptocurrency as well as other major cryptocurrencies. And we're trying to do this with the recurrent neural network. So, let's continue. The next thing that we want to do here is we're going to import time, so we're going to use that just in a moment. And we need to create a few more constants here. The first one we're going to do is epochs. So how many epochs do we want to train this model for? Then we're going to go with a batch size, and we're going to go with 64 to start. We can tinker with that later if we wanted. And then finally, we're going to go with a name, and we're going to make this an F string. And what you want is a name that is descriptive of the model, because generally you're going to tinker a little bit with the model, tweak it a little bit here and there, rerun it again, and then you're going to do the same thing again. Hopefully you don't have as itchy of eyes as I do. Anyway, so you want to have a unique name both for the model that you save as well as in TensorBoard, so later you can compare the results of a bunch of different models and you don't have to be like, I don't know what model that was. So, or worse, you overwrite the other models. So anyways, yeah, so let's come up with a good name. So I'm going to go with sequence length dash sequence dash future period predict dash predict dash, and then we'll just throw in an int time.time here. And that should be good enough. That'll give us a nice, unique model name. So now what we're going to do is import all the TensorFlow stuff that we need. So import TensorFlow as TF, stop it, Sublime. From TensorFlow.Keras.models, we're going to import sequential. There we go. Oh, you're such a sequence, dude. Oh, this might be a hard one to get through. From TensorFlow.Keras.layers, we're going to import dense dropout, LSTM, probably also cuDNN LST. Dude, no, I had it right. LSTM, and then batch normalization. All of these we've seen, except for I don't remember if we've done batch normalization. I apologize if I've already covered it. Basically, it's just normalization, but between the layers. So for the same reason you want to normalize your input data, batch normalization can be useful from layer to layer, because really you can think of each layer, if it's going to another layer, that layer, its output is kind of like it's a new input for a new layer. So you would want to, if you could, normalize that data. So we're going to do batch normalization there. Okay, once we've got that, more imports from TensorFlow.Keras.callbacks. We want to import TensorBoard, oh my God. Why can't I type right now? Anyway, TensorBoard and model checkpoint. I think B in TensorBoard probably needs to be capitalized. It does. Okay, TensorBoard, we've really already seen this callback. Model checkpoint is a fancy-dancy little callback where basically you can set various parameters as to when you want to save certain checkpoints. So I like to use validation accuracy. I think it's a pretty good one. Validation loss would be another good one. Basically, each time it reaches a new max, you can have the model actually save that checkpoint. That way, you can run for 100 epochs. Now, probably at the end of 100 epochs, before you got there, the model overfit and it kind of went crappy. And you could save every single epoch, but this might waste space or whatever. Anyway, this just makes a nice way to always save the best one. Okay. Once we have that, we're going to scroll on down. We've got our train X, train Y, validation X, validation Y, ready to build the model. So, make some space here. And we're just going to, a lot of this code is stuff we've seen before. So again, model is a sequential model. We've seen that one. model.add, and we're going to add, I'm going to use cuDNN LSTM. If you're on CPU version of TensorFlow, use a regular LSTM. It's going to be 128 nodes in this layer, and input shape. Man, something bangs on this desk and it makes me mad. That. What is that noise? I can never find what that noise is. It drives me nuts. And then sometimes it like stops happening for like months and then it comes back. Anyway, input shape train x, train x.shape 1:. That was about to be an error that was not going to be fun to debug. Gotta figure out where we are now. So we're inside the cuDNN LSTM still. Yes. So then return underscore sequences equals true. So you should already know that what the next layer is going to be. Are we good? Why is it doing? Why is it? Because we don't have a new line, and then this is maybe pep8. Yeah. Okay. All right. So then model.add, and we will throw in a dropout, and we're going to do 0.2. Then we'll add a batch normalization. So model.add batch normalization, and no parameters there. And then I am going to copy this and then paste it twice. Paste and paste. And then we're going to have a dense layer. So because we're going to have a dense layer, I'm going to remove the return sequences. And so now it's a 128 to another 128 and then to a final 128. Now, for whatever reason, in my notes, I have this as a dropout of 0.1. So I'm going to leave that there. But I'm pretty confident 0.2 would probably work just as good. Anyway, I'll move it back to 0.1. And I think we'll leave everything else as the same. Now, we're going to add a dense layer, but not the output layer, just a dense layer. Model.add. Yes, that one. Dense 32. Activation will be rectified linear, which reminds me, if you can't use cuDNN LSTM, make sure you throw in some activations. I would do either TANH, because that's what cuDNN LSTM is using, or you could just use rectified linear. So we've got that dense layer. Cool. Model.add. We'll throw in a dropout. 0.2. I really wonder if this was like a typo or what. Everybody else is 0.2 except for this layer. So anyway, and then finally we need the final dense layer. This is a binary choice, so it should be only two options there. Activation, because it's the output layer, softmax. Okay. Now that we've got that, we're ready to specify the optimizer. We'll go with tf.keras.optimizers.atom with a learning rate of 0.001, 1e-3, and a decay of 1e-6. And then we'll do the model.compile. And we'll go with loss is sparse categorical cross entropy. You could also go with like binary cross entropy. Next, what we're going to do is optimizer is the optimizer that we defined. And then metrics, we will go with accuracy. Okay. Cool. The next thing is we need to define our callbacks, and I guess we can fix this, make Sublime happy. So we have two callbacks that we want to do. That one is TensorBoard, which we've really already seen, and so that's just going to be a TensorBoard object, logdir equals logs. And then we'll do some formatting here, and in my text-based version, I haven't made this an f-string. I'm trying to move completely to f-strings. They are better. It's just I'm so used to, doing the format, but it's so much nicer to use f-strings, to be honest, to like build it out and then not have to remember what order things are in, and then later the worst thing is like when you build it for the first time, it's really no big deal, but then if you want to like go in and move things around or like add a bunch more, it really does it's kind of challenging with string formatting, whereas with like the f-strings, it's just a a breeze. Okay, so that's our TensorBoard object. The next thing we're ready to do is do the checkpoint object. So here, file path, and to be quite honest with you, this is not my code. I basically searched for the like an example for the checkpoint thing. So this might be from like Keras documentation. I don't even remember where I found this. But basically, we'll do RNN final. Obviously, they didn't have this exact name, but then it's epoch, and then 0 to D. And the reason why I'm doing this is, I kind of want to just like copy and paste this in so I can talk about it and not waste a bunch of time. Here, paste. So, like, I'm not sure how you're formatting, because obviously this here is a string formatting object to this file .model, and then we .format the file path, but then it's like monitor. I guess I just don't understand how these values are eventually getting passed into here with a .format. I don't know. Anyway, what I want is epoch and validation accuracy, and this code works. And again, I don't, because obviously, you know, format file path, it throws in the file path, but then it's like these other things in the format. Anyway, I don't get it. I don't know how it works, but it works. Anyways, so now we're going to do a history equals model.fit. We're going to fit train X, train Y. The batch size is just batch size. Epochs is going to equal epochs, capitals. Let's fix this. They are parameters, therefore no spaces. After epochs, we have the validation underscore data, and then in here we have validation X, validation Y, and then finally we have our callbacks that we want to run. So that's TensorBoard and checkpoint. Okay, and then once that's done, I do run an evaluate in the text-based version, but really every epoch should be running validation data anyways. So at the end, I guess we could just do a model.save, although even here, I'm not really sure what the point is because the model checkpoint is going to be saved. So I guess we're done at this point. Okay, save that, and now let's go ahead and run this thing. Pi-36 crypto RNN. Let's see if we have any errors. Faster, please. I'm impatient. Nothing yet. Come on. Okay, it starts training. Already at 51-ish accuracy. The epochs are not too slow. I think I'll probably pause it or just chop this out. But we can also watch it as it trains with a tensor. No. What have you done? It went to save it and then, oh. Probably because we don't have a models directory. Let's just throw one in real quick. Models. Dang it. Oh. Well, here's a perfect example why you want to throw in time to your name, because you're going to fix the bug, you're going to rerun it, and then you're going to be like, dang it, I didn't change the name. And then it's going to overwrite it in the logs. And now it doesn't matter. Now there's two of them by timestamp. Although, actually, why that's, oh no, it's not the same. Dude, I can't see at all clearly. Anyway, those look the same. You know, give me a break. They're, 3 versus 8. Anyways. Okay. I think I need some alcohol. Anyways, that would definitely help the situation. Okay, so back to our TensorBoard. TensorBoard logdir equals logs. So why is this dash dash logdir with no underscore? And then this here is, oh shoot. Yeah. This here has an underscore. Drives me nuts because it really always confuses me every time. Okay, so then we can go to our browser, go to our PC. You could always go to 127.001:6006 if you don't know. But anyways, HPC for me is my PC's name. Okay, so the blue line is what's my GPU might have just crashed. Hopefully this recording isn't borked. What is happening? Like, what is this? You guys can't see it, but my entire desktop just like went black and all of my icons went bonkers. Anyway, hopefully it's still recording. Okay, so we're currently 5 epochs in. Let me refresh the page. Hopefully we'll get proper scaling here. There we go. Okay, so this is our model. And we're actually doing pretty good. Validation loss has fallen for the first 5 epochs at least. Validation accuracy has gone up. Again, we are seeing what appears to be, in general, better validation accuracy than in-sample accuracy, which probably shouldn't be the case, because this is always going up. We'll see if that remains the case. But like I said before, a lot of times you will have like a higher validation accuracy if the model still has a lot to learn or it's learning a lot per epoch. You might find yourself having, at least initially, a slightly higher validation accuracy because the validation accuracy is calculated at the end of the epoch, whereas the accuracy here is for the entire epoch. So the initial bit of the epoch is kind of weighing it down. Anyways, accuracy in sample and out of sample, I'm just going to do this, both look pretty good. And then loss looks really great here. And validation loss rather looks pretty good for the first really like 6 epochs, and then it kind of looks like it's turning around. And then you can even see validation accuracy is kind of doing the same thing. After about 6 epochs, it starts falling. But we had about as high as 57.28% accuracy, which is pretty darn good. So the other thing we probably should have in our name here is the thing that we're predicting. So I would also throw in ratio to predict. So now what we could do is let's change this to Ethereum and do Ethereum USD, and then come over here and rerun that. And hopefully my GPU won't cry too hard. I probably should have set GPU usage to like 75%. My mistake. Let's see. Hold on. Do we have even less data here? Oh, no. We actually have more data for this one. So this is for Ethereum by watching the other prices. So we're already at 51%, so that's pretty good. Okay, so here is Ethereum done. So Ethereum is our red line here. Blue is the Litecoin. So at the end, the validation accuracy is about the same, but for the most part, before things started to turn around, a little bit below, but pretty similar results. Validation loss similar. They kind of diverge in a lot of places, but still pretty similar trends. After about the 6th epoch, things just kind of go south. Anyways, I am now running Bitcoin Cash. We'll see how that does, and then after that, I'll run the Bitcoin, and then we can kind of see how everything relates. Okay, Bitcoin Cash is done, and actually it's the best performing one of all of them in terms of validation accuracy and loss in both. It has the least loss and the highest accuracies. Pretty cool. Finally, we are going to run Bitcoin and see how that does. I'm interested to see Bitcoin now. Again, I actually don't know the results. I probably should have found this out before, but pretty good results. Maybe I should keep this all to myself. Okay, and Bitcoin is done. Very interesting results on Bitcoin. Initially, it was just kind of 50, just 50% the whole way, and then obviously somewhere around the 5th epoch, it figured something else something out, started dropping, and then obviously validation accuracy started going up, validation loss started going down, although briefly it did spike up. So that's actually interesting. That's way better validation accuracy than I thought Bitcoin would ever get, just because Bitcoin, there's probably just a whole lot less alpha involved with Bitcoin nowadays. But also I think Bitcoin is more of the trendsetter, but then again, maybe not. I mean, I think a lot of these other crypto coins have a lot more of an established presence than just relying on the price of Bitcoin. So anyways, pretty cool results that we were able to seemingly predict forward movement to a pretty good degree. I mean, I kind of draw a threshold around 60% for like a pretty impressive classifier when it comes to predicting finance. And in this case, this is predicting just simply an upward or downward movement. So I think you could probably tweak this model. I mean, I didn't spend too long on the model. All I did was I just wanted to find a model that started to learn. From here, I would probably write a script to just kind of automate the rest of everything. But I'm pretty confident we could get probably all of these over 60%. And that's just off of pricing and volume features. So then you'd probably start bringing in other features besides that. But anyways, pretty cool. I will just say, though, this is seemingly good. As I said before, probably a few times, it's so easy to make mistakes on projects like this. So obviously use this at your own risk. I'm not responsible for anybody who actually uses this and destroys their trading accounts. I'd go so far as to say there's almost certainly a bug in here. So yeah, educational use only, please. So anyways, pretty cool results. Let me know if you guys tweak it and can get better results and all that, or if you don't want to talk about it, I guess that's fine too. Anyway, keep it all to yourself. Pretty cool. That's it for this project for now. I don't really know what I want to do next in this series. I'm probably done with like basics Keras because I'm running out of things to do besides getting like super complicated like we did here. The next thing I'd really like to get into as far as just kind of playing around with things is audio, either with songs or speech or something like that. I want to do audio. So anyway, let me know what you guys think about doing audio with this stuff. Also, if you have anything else you really want me to get into, let me know down below. If you have questions about anything in here, feel free to ask. You can also come and join the Discord. It's just discord.gg/Centex. If you spot an error or have something you'd like to improve upon the script, you can let us know in the comment section or via Discord again. Otherwise, that is all for now. I will see you guys in another video.